Today we're going to talk about section 6.6, which is polar coordinates. Polar coordinates is a different way of graphing things. It's a different way of labeling them, and we're going to talk about how to go between what we know, the rectangular coordinates, and this new polar coordinates. In rectangular coordinates, we had two axes, the x-axis, which was the independent axis, and the y-axis, the dependent, and we had an origin. And all our points were labeled x, comma, y. That was how far we went on the x-axis, comma, how far we went on the y-axis. Those are rectangular coordinates. For polar coordinates, we look at the same points, but instead of having our x and y axis, we measure how far we are from the center and what angle we are off of this positive x-axis, which is called the polar axis in this case. The center is called the pole, and our points are all labeled r, comma, theta. And r is how far away they are from the origin or from the pole, and the theta is the angle up here. So for example, point A, we are 1, 2, 3 spaces away from the pole, and we're up 30 degrees. Remember, if you're labeling your angles in degrees, you must have a degree sign there. If there's no degree sign, that means we're in radians. A lot of these we're going to use degrees, but we will have some where we use radians, so make sure you know the difference. Now, graph paper. This uses a regular old grid. This is a totally separate kind of graph paper. I will have graph paper copied for you, or you can find some on the internet to print off yourself if you want. But you will need some graph paper to look at these different graphs. There's also some in your Chapter 6 project. So let's try working with these a little bit. Let's say we have a point to 45 degrees. Well, if we have our graph, let's see here. This is going to take me a little bit longer than you guys because I won't have the graph paper. So 45 degrees is halfway between the 0 degree line and the 90 degree line. And we went up 2, so our point would be right here, because this line here is 45 degrees. Your polar graph paper doesn't always have the angles marked off the same way, so you have to make sure you're paying attention to how they're marked off. And the one I just showed you, I had 30 degrees marked off and 60 degrees, but not the 45, so I would have had to put my point between the 30 and the 60. What about if I have the point 1, comma, negative 30 degrees? Well, negative, remember, is down this way, so negative 30 degrees is about here. It's also 330 degrees, remember? And if I went 1 that way, then my point would be right here. What if I did this? What if I said negative 1, comma, 45 degrees? Well, if I go in 45 degrees, that's up to here, and then I went negative 1 in that same direction, so there's my 45 degrees, and then I'm going negative 1. That means I'm going away from the pole in the opposite direction. So my negative 1, comma, 45 degrees would be right there. So there's some examples on how to graph those points. Now, a lot of times you need to be able to go between rectangular coordinates and polar coordinates. So we need to see how those are related. So let's look at that. If we have just a regular rectangular grid and we have a point out here, we know that for our polar coordinates, this length here is r and this length is theta. And for our rectangular coordinates, we've got this length here is x, and this length here is y. Because remember, these are graphing the same points. It's just whether we overlay grid graph paper or polar graph paper. So it's the same points. So how do we relate all these? Well, we know a whole lot of trig that will help us to relate those. So if we want to go, let's say we want to go from rectangular to polar coordinates. Well, we know, we can look at this Pythagorean theorem. We know x squared plus y squared equals r squared. So if we know x and y, we can plug that in, figure out what r is. R is the square root of x squared plus y squared. Now, normally when we take our square root, remember we do plus or minus, but we're talking about a distance, a length here, so it's always the positive. If we know what x and y are, and we want to know what theta is, we know that the tangent of theta is equal to y over x. So that means theta is the inverse tangent of y over x. So we have these two ways to change from rectangular coordinates to polar coordinates. Now, what if I want to go the other way? What if I want to go polar coordinates to rectangular coordinates? In other words, I know r and theta, but I don't know x and y. Well, if I know r and theta, I know that the cosine of theta is equal to adjacent x over the hypotenuse r. So that means my x is equal to r cosine theta. I can do the same thing with sine to get my y. I know that sine theta is y over r, so that means y equals r sine theta. So if I know r and theta, I can find x and I can find y. Just remember, if you're looking at a degrees angle measure, then make sure your calculator is in degree mode. And if you're looking at radians, make sure you're in radian mode. Pay very close attention to those modes. All right, so let's try some examples. Let's say we're looking on if we want our angle measure to be, let's say this should be theta. If theta should be between 0 and 360 degrees, because remember, you can go round and round on these and have equal measurements of your angles. If I want to convert to polar coordinates from some rectangular coordinates, let's say I start out with this rectangular coordinate, -3, 4. If I want to convert that to polar coordinates, well, I know that r is equal to the square root of x squared plus y squared. So that's the square root of 9 plus 16. 9 plus 16 is 25. The square root of 25 is 5, so my r is 5. And I know my theta is the inverse tangent of y over x. Now, remember, you need to pay attention to what quadrant you're in here. We are -3, +4, so we're over here in the second quadrant. So we need to make sure our angle agrees with that. When you type this in your calculator, you're not going to get an angle in the second quadrant. Remember, your calculator is going to give you a positive up here and the negative down here. So you have to recalculate that to get what goes over here. It'll give you this negative down here. So you add 180 to that, and you get 126.87. So my rectangular coordinates of -3, 4 changes to polar coordinates of 5, 126.87 degrees. All right, here's another one. 5, -12. All right, pause the video and turn this one into polar coordinates so that you can check and make sure you know how to do that. So we have r is equal to the square root of x squared plus y squared. So 144 plus 25 is 169. Take the square root. You should have gotten 13. And our theta, well, we know we're in the fourth quadrant, but we want our angle measures between 0 and 360. So we take the inverse tangent of -12 over 5, keeping in mind what we get. we got a negative answer, so we take 360 minus that so we can get our fourth quadrant answer that we want, and we get 292.62 degrees, which means our polar coordinates are 13, 292.62 degrees. So that's rectangular to polar. Let's try the other way. What if we're going polar to rectangular? Well, let's try 4, 5 pi over 6. Notice, no degree sign here. This is radians. So we know that x equals r times the cosine of theta. We know that the cosine of 5 pi over 6 is a unit circle cosine, so that means it's negative square root of 3 over 2, which you should know because you know your unit circle so well. So that's negative 2 times the square root of 3. And our y is equal to r times the sine of theta. And we know that the sine of 5 pi over 6 is 1/2. So that's 2. So our rectangular coordinates are negative 2 on the square root of 3, 2. All right, you try this one. And see if you can get that. Pause it, change this, and get your answer. So we have x equals r times the cosine of theta. Make sure you're in degree mode, and you should get 3 for that. And y is r times the sine of theta. Make sure you're in degree mode, 3 on the square root of 3. Now, on this one, you can check it. You know 5 pi over 6 is over here, so you're over here somewhere. And look, negative x, positive y, so you're in the second quadrant. This one, 240 degrees is over here somewhere, but we went negative 6 in that direction, so we're up here somewhere. And positive x, positive y, first quadrant, so we're good to go there. Now, what happens if we have equations for different conics or different lines or things like that, pictures, and we want to change those between polar and rectangular form? Well, we use what we know already. So let's say we have this rectangular equation. We know this is a line. X and y are both in first degree. So we know it's a line, but we can change it to polar coordinates by simply replacing x and y with what we know they are in polar coordinates, using our information we found from that triangle earlier. Now, when you have an equation in polar form, you usually solve for r. So in this case, we'll factor out an r. And then solve for r. R equals 14 divided by 3 cosine theta plus 2 sine theta. So this started with a rectangular, we knew it was a line, and we get to this polar coordinates. Sometimes with the polar coordinates it's harder to tell what shape it is, what locus of points is what it's called. And this locus of points is a line. But a lot of times we have to switch it. We have to be in rectangular form to tell that. So let's say we're given a rectangular or a polar form of an equation, r equals 10 times the sine of theta, and we want to make that into rectangular form. Well, we know that x equals r times the cosine of theta and y equals r times the sine of theta. So we need to get this to look like something we have over here without changing the equation. So what we want to do is if we multiply both sides by r, then we have our r sine theta. And we also know that x squared plus y squared equals r squared, which gives us that over here. So if we multiply both sides times r, we haven't changed the equation. We end up with 10 r sine theta. So r squared is x squared plus y squared equals 10 y, because y is r sine theta. Now, we look at this and we say, okay, this is a conic. So we need to kind of rearrange it so we can figure out what kind of conic. Or actually, you should know what kind of conic it is already, because our coefficients here are equal, so you know that's a circle. So the locus of the points is a circle. So we just need to find some things out. We need to figure out where the center is and where that the radius is. So we put this like this. Remember how we did this. Now we complete the square. Whatever you do to one side, you've got to do to the other, so you're not changing anything. So we have x squared plus y minus 5 squared equals 25. So this tells us it is a circle. We knew it was a circle here because our coefficients in front of our squared terms are equal to each other and not 0. So this tells us it's a circle. That's the locus of points, a circle. We named the locus of points. The center is at 0, 5. Remember, h is 0, k is 5. And our radius is equal to 5. This is the square root of this number here. So when they ask you for name the locus of points, that's this. And the location is where you tell about the center, the radius, the major minor axis, the asymptotes, all those kind of things, depending on what kind of conic it is, so that you would be able to graph it. So here we would have this circle. And our center, 1, 2, 3, 4, 5. Our center is here. So our radius is 5. So we go up 5, down 5, left 5, right 5, and we end up with a circle. If you have even graph paper, it'll look better. But that's our circle. That's what this r equals 10 sine theta looks like, this circle here. So polar coordinates is just a different way to write the same things that we have from rectangular coordinates. You need to be able to go back and forth between them, and you need to understand how to graph those polar coordinates. Make sure you've read the section and take notes on it so that we can discuss this in class.